There you are. Today we're going to do another instructional video. This time it's going to be on Little Mo, our little seismometer.
Alright, so this is Little Mo. Our little seismometer, hence his name. And he's basically a simplified version of the seismometers that we would actually use in the field, but he still functions with the same basic, in the same basic ways. Seismometers are machines that are used to record seismic signals or seismic waves. And seismic waves, they can be generated in a lot of ways. They are energy waves that basically spread out from the source of any kind of energy causing event. Like typically seismic waves are generated by earthquakes, where we have a sudden motion in the earth which causes energy waves to propagate throughout the earth in every direction. But seismic waves can also come from any kind of impact, like or something like that. And so seismometers, basically they are able to measure any kind of shaking that we have in the ground caused by seismic waves. So if there's any kind of impact on the table, these seismic waves will travel from the point of impact all throughout the surface and subsurface of the table, and then those waves will travel towards the base of the seismometer, and then we will be able to pick up on those waves using our seismometer and the signal that we produce from it. And this can tell us things about what the point of impact is like and properties of the surface that the waves are traveling through.
Alright, Little Mo is an electromagnetic seismometer. He's composed of a casing, a spring, a magnet connected to the spring, and a lower magnet connected to the first. Surrounding the top magnet is a coil of copper wire, and around the bottom magnet there is a copper tube. Okay, so during a seismic event, it causes the ground to shake.
Any shaking will cause the spring here to move up and down. It's going to shake. And then the spring is attached to the magnet you can see in there. And so any shaking from the spring is going to cause the magnet to shake. And the shaking of the magnet is going to cause a change in the magnetic field. And then this change in the magnetic field is going to induce a current in this loop of copper wire here. And then this copper wire, the current is converted to a voltage, which is done by the little computer chip you see at the base here. And then Little Mo is connected by this wire to our laptop, and then we can see this voltage signal from the seismometer here on our screen, so we can see what the seismic signal looks like. So we don't want the signal from Little Mo to ring on forever and ever and ever, and so for this purpose we use this secondary magnet and this copper tube, which will damp the motion of the entire system. And so when this secondary magnet moves, because it's attached to the rest of the system, an electromagnetic force will be generated in the copper tube, which will oppose the motion of the magnet, and so it'll slow the magnet down and therefore the whole system, damping the motion and getting us back to a stationary system.
Alright, as for troubleshooting, you're going to want to make sure Little Mo is lined up well and the magnets are not touching any of the tubes in here. You can use these little screws and fiddle with them a bit to make sure things are lined up. Also, the base has 3 little screws that you can adjust so the bottom is leveled out. And then as it's connected to the computer, if you're using this computer, this is the port that works. The other ports don't work for some reason. And then you can bring up jAmaSeis to view the waves.
So this is the laptop that's connected to Little Mo, and so we have 3 seismometer signals here. This one in the middle is Little Mo. You can see it's labeled Munnell, St. John's, NL. This top one is recording from a seismometer in Massachusetts, and this bottom one is recording from a seismometer in Vancouver. And so this is the signal that we care about because this is our signal from Little Mo. And there's a few different options you have for displaying the signal. And so the main button that I use is scaling the data. And so right now we have magnification 5. If you find that the signal is not showing up very well, you can increase the magnification. And so you can see the signal gets bigger. Bring it back down because 5 is doing pretty well for us. And you can also go to the jAmaSeis button up here, preferences, and then you have a few different options here as well. You can change the time per line. So right now, each line from left to right is showing a time span of 10 minutes. And you can also change the amount of lines that you have if you want to show more history of the seismic signal. Right now, I just have it on 1 because that's easiest, but you can go up to 24 lines. Don't recommend that because your signal or your screen's going to get pretty cluttered. Maybe you just have 2 or 4 or 1.
All right, so now that we have our setup set up, we can produce some seismic waves and see if Little Mo will detect it, and then we can see it on the computer.
So right now we can see the signal from Little Mo is pretty quiet. There's no shaking or anything happening right now. But we can generate some seismic waves by doing a light impact on the table. And now we can see that we have a shaking signal happening here. And so it'll just kind of reverberate like this for a bit. And that's kind of what the signal from any minor impacts look like.
Well, we can stop the table, as simple as that. We can also do a bunch of other things. And that's what that looked like. While Little Mo can pick up local movements like us stomping, it can also pick up earthquakes that happen near New Zealand. And these are the surface waves and this PNS packet from that. And that happened in 2016. And we were able to pick it up because the magnitude of the earthquake was so strong at 7.8 on the Richter scale. You can stop at 5 or 6 seismometers, or just 1. Thanks for joining us for another instructional video of us and just hanging out with Little Mo. I hope you join us again next time, where we'll have a sweet, fun time learning about the basics of geophysics and other fun setups. Thanks for joining us again. Don't worry about it.